Okay, so we will do another problem on forces on a submerged surface. So you have in the following problem an aquarium and which contains seawater. Gamma of seawater is given and the depth of water in this aquarium is 1 feet. We want to repair some damage to one corner of the tank, which has a triangular section. So we want to replace the damaged part by this triangular section, and we want to know what is the force of water acting on this part to know which material to use. Okay. So the question here is to find what is the magnitude of the force acting on this triangular part and what is the location of this force. So let us look at our figure. We are in the case of a flat surface and we want to determine the action of water on this surface. So if you remember, we developed together formulas to give us the force and the location for an inclined surface. So here, since we developed our formulas that are general for any angle theta, if your surface is now vertical, theta will be equal to what? What will be the value of theta then? All you have to do is to replace in your formula theta by 90 degrees. Okay? So now, first, let us determine what is the magnitude of this force. What is a horizontal? Here it's horizontal force. Why? Because the surface is vertical. So the horizontal force acting on your triangle is equal to gamma of the fluid, gamma water, times the pressure at C, which is the centroid of this area. Okay? So now you should determine what is the pressure at your centroid. You know that for a triangle, if I consider a triangle, the centroid point C is located at h over 3. So if this is height h, then the centroid is located at h over 3 from the base. So this distance is h over 3. And here the value of h is 0.3 feet. So h is given. Then I know that from the bottom, the distance of C from the bottom is equal to 0.3 over 3, which is equal to 0.1.
دكتور بس ما عرفت لا h over 3.
اوكي لانه التراينجل انت اذا بتتذكر بالماس في عندك فورمولا شيت for each shape. يعني اذا عندي rectangle بيكون السنترويد at h over 2. اوكي. For a triangle بيكون يعني هيدي mathematical property فيك تعمل لها demonstration by integral procedure. يعني احنا بنعرف for any shape تلاقي the position of the centroid you can do xc times total area equals to integral x dA. بس بما انه it's a known shape هون, it's a triangle, you can directly use the formula sheet result اللي هي انه اذا عندي triangle and I know that the height is h, then the centroid will be at h over 3 from the base. Okay, and هذه mathematical properties that you can use directly.
Okay, doctor.
Okay. So now we know that the centroid is at 0.1 feet from the base. So the distance from the centroid to the free surface will be 1 feet minus 0.1. So the depth of the centroid will be 0.9 feet. And then now I can say that the pressure at the centroid, okay, can be replaced by the atmospherical pressure or P0, which is the pressure at the surface. When they don't mention anything, you can consider that it can be negligible. Okay. So whenever it's exposed to atmosphere, then you can consider that P0 can be neglected compared to the pressure created by the column of water, which is here you have that the value of sorry, here it's area times PC, okay? And PC will be written as gamma water, okay? So you have the area times P0 plus gamma water times the depth of C, so times H of C, okay? So now we said that P0 can be neglected compared to the other term, so it will be cancelled out. Now concerning the area of our surface, you have a triangular surface. So you will put that all you have to do is to multiply the base times the height over 2. So your area A in this problem here is 0.3 times 0.3 over 2. This is the area of your surface, and you are interested into finding the force acting on this area. Now, for the pressure PC, as we neglected P0, gamma water is given. So it's rho times G of water, and H of C is simply 0.9 feet. Now, don't worry about units, okay? Here we are using English units. So keep in mind when we are using English units, you have, instead of meter, you have feet. Instead of, for area meter square, it's feet square. And for the value of your gamma, okay, in SI units, gamma is specific weight. It's Newton per meter cube. In SI units, in English units, gamma will be in lb per feet cube. And here they directly provided you gamma in the corresponding unit. They told you that so if we go back to the given, okay, gamma of water is given already in lb per feet cube, and all lengths are given in feet, so you don't have to do any conversion here. And in case length is given in inch, just convert it to feet and you can proceed. Okay. So, and keep in mind that in English system, if they give you rho, for example, and you want to find gamma by doing rho times G, the value of G is 32.2 feet per second square. Okay, so it's not 9.81, just remember this. So now we have calculated the value. Yes. Sorry, the voice is lagging a lot. Can you type your question?
الفاليو تبع جي هي given او نحن
لا هون ما في لزوم نستعمل جي لانه اعطونا جاما دغري. Okay, they gave us gamma, but what is gamma? Gamma is rho times g. يعني إذا instead of giving gamma, if they give you the density rho, okay, rho will be in إذا هي بال SI units, rho is in kilogram per meter cube. بهيك problem مفروض إذا بدهم يجيك تشتغل English units, they will give you rho in slug. يعني الايكويفالنت للكيلوغرام هو slug بالانجلش units. So slug per feet cube. إذا أعطوني rho in slug per feet cube, كيف بجيب gamma? To be able to get gamma, I should multiply by G. Okay, and G is in English system. He is 32.2 feet per second square. Okay. Here you don't need this لأنه دغري أعطوك gamma اللي هي product of rho times G. But if they give you just rho and you want to find gamma, you should multiply it by G. Okay.
Okay, doctor.
Okay. So now we got the value of FR. Now we will move to the point of application. Keep in mind إنه the point of application of the resultant force منه على centroid of the surface, because we have developed together, okay, we have developed together in the previous sessions that we can find coordinates of X center of pressure and Y center of pressure using which formulas? So if you remember, I will tell you here, going back to the course material, here we derived together the formula that should be used to determine the center of pressure. Okay, so as you can see here, the location of the center of pressure is xc plus the product ixy over ayc, while, and if you remember when we derived this equation, what was the condition? I told you can apply it if P0 is negligible compared to the pressure created by the fluid. If not, if P0 is not negligible, this is the general formula you can use. But in this problem, the one we are using, P0 is negligible. So you can just directly apply this one to get X of the center of pressure. And you can apply, for Y, you can apply this relation. For Y, you have that Y prime is equal to YC plus IXX over AYC. Okay? So here, let us find Y of the center of pressure using this formula. First, for YC, YC represents, if you remember, what is YC? Going back to the figure, you consider an origin at the free surface. Okay, you have the origin at the free surface. YC represents the distance between the origin and your centroid. Okay, here in our problem, since theta is 90 degrees, H of C and Y of C will be equivalent. Okay, because when you have your surface vertical, theta becomes equal to 90, then the depth of your point centroid is equivalent to Y of your centroid. So already we determined together what is Y of C. Y of C is 0.9 feet. We still need to determine what is the second area, the second moment of area. If you remember, this term IXX is called the second moment of area about the x-axis. And this is a property of the geometry of the surface. So if you have a rectangle, you will have a certain formula. If you have a triangle, you will have another formula. So now we will go to the formula sheet that that is provided to us, and we can see here that for a triangle, first for the triangle, as you can see, if I consider the centroid from the figure here, the centroid is at b over 3, where b is the height. This is the property we use together now to calculate the position of C. So here, instead of calling the height h, they called it b. So as you can see, the centroid is located at b over 3 from the base. And now, if you want to determine what is the second moment of area about x-axis passing by C, so if we consider x-axis passing by C, then you have the base that is parallel to x-axis has a certain length, A. So first you need to determine what is the base length parallel to x. You need to determine what is the height of your triangle. And here they are given in the problem we have. Because if we go back to the problem, this is the shape of our triangle. It's a right triangle, so it's a particular case. It's a right triangle. The base is equal to 0.3. And its height is also equal to 0.3. So if you want to apply the relation from the formula sheet here, A here is the base, which is equal to 0.3. And B value, which is the height, also is equal to 0.3. So when we want to calculate for this shape IXX, okay, then IXX will be equal to AB cubed over 36. So just we have to use the formula that we have here. So it's AB cubed over 36, which is equal to 0.3 to the power 4 here, because A and B are equal. So 0.6 to the power 4 over 36. So now we have the value of the inertia, of the value of the second moment of area I about the x-axis. Then all we have to do is to go to our problem again and replace. Okay, so here I will replace Ix by its value. I already know Yc, So if you remember, YC is the distance from the free surface to the centroid. It's 0.9 feet. And the area was already calculated. So now you are ready to find the numerical value. All you have to do is to replace. Okay. Any question on how we found the position of YCP? Now for XCP, you can use the formula of the derivation we did last time. And you can use that X of center of pressure. So X of center of pressure is equal to the product IXY over YCA plus X of C. Okay, you can do this, or you can, because it's a triangle, okay, you have the property here that your center of pressure will be on the median line. So as long as you determined Y, so now you know the value, of YCP, and you know that your center of pressure will be on the median line of your triangle, then you can locate your center of pressure, because it will be the intersection of this line, which is at YCP, and the median. So this will allow you to determine the position of your center of pressure. Okay. Any question on this? How we determine the location of the point of application of the force? Okay. Now we will move to another section, okay, which is how to determine the pressure forces on a curved submerged surface. So this is an example. You have a dam, and the surface of your dam is not flat. You have a certain curvature, okay? The purpose is to determine, if I have a curved surface, what will be the resultant action of the fluid. So it's similar in concept to what we did already, okay? But what is new for us is that we are considering a curved surface, not just a flat surface, okay? So how we will proceed with the analysis? To be able to determine what are the expressions of F horizontal and F vertical, what we will do is the following. We will consider the surface of interest, okay? So let's say this is our surface of interest, and we have fluid above it. We have a column of fluid above the surface. The idea is the following. You know that in general, any two objects in contact, by principle of action-reaction, the force of the surface on water, so the resultant force of surface, of the curved surface on water, is equal in magnitude and direction and opposite in sense to the action of F water on the surface. Okay? So the idea here will be, if I can find what is the force of the surface on water, I deduce by principle of action-reaction the force of water on the surface. This is why what we will do, we will take as control volume, the control volume of water above the curved surface. And we will draw its free body diagram. If you remember from dynamics, what is the free body diagram? You remember what is the free body diagram of a certain control volume?
In كل forces عليها.
Exactly. We represent all forces acting on this part of fluid. Okay? So if you consider the following figure here, I have this part of water above my curved surface, and I will take this column as my system, and I will start to write what are the forces on this part. So this is our control volume, everything that is above my curved surface. And I will consider that I should draw the free body diagram, which will represent all forces acting on my control volume. Now, what do we have? You have the weight of air due to atmospherical force. So here, if you want, in general, the weight of air, we can neglect it, okay? But in case we don't want to neglect the effect of air, the weight of air can be, if you want, modeled as what? You know that at the atmospherical level, air will exert a certain force on the surface of fluid. This force is equal to what? So if I know the pressure of air here, if I know the pressure of air at this level, P atmospheric, or it can be, if you want, any pressure that I can impose. You can impose any pressure here. Just you have to multiply this pressure by the area. This will give you the force acting on D. Now, what are other forces acting on my control volume? I have the weight W1 of this part, the rectangular part, and I have W2, the weight of this curved part. Okay, so W2 is the weight of the following part. This is concerning the weight of bodies we have. Now, since this fluid is supported by the curved surface, the curved surface will do an action on water. So as we said, we will determine the resultant force, F resultant of curved surface on the fluid, and by action reaction, once we find what are FH and FB, we will deduce the action of water on the surface by action reaction. So it will just be equal in magnitude, same direction, but opposite sides. Okay. Now, since I don't know exactly what is FR of the curved surface on the fluid, I don't know its direction, I can divide it into two components, one horizontal and one vertical. So to be able to find what is F of the curve on the fluid, I should determine what is the horizontal component and what is the vertical component of the surface action on the fluid. Okay. To be able to find these forces, all we have to do is to apply equilibrium conditions, because we are working in static case. Okay, so since we are working in static case, we can write that sum of forces in the vertical direction is equal to 0, and sum of forces along the horizontal direction is equal to 0. Okay, so let us talk about, we have considered these forces, FB and FH, but we still have external forces acting on our control volume. So we said that the action of the curved surface on the control volume will be accounted by these two components, FH and FB. Now, our control volume has other boundaries. It has boundaries BE, DC, and CA. Okay. Already we said at DE here we have, let's say, the atmospherical action. We consider it. And now, what about the actions on CD and BE? They are due, okay, they are due to water molecules, because here you have water molecules. Okay. And here you might have water molecules, or you might have a certain vertical surface. So in all cases, these two forces will cancel out due to symmetrical effect. You know why? Because here, if you consider pressures from this level of water, they will be equal to pressures from this side, because you are at the same horizontal level. Okay, so you are at the same horizontal level in a static fluid. This means that the pressure is the same everywhere, and since it's the same total area, so you have here a horizontal surface, a vertical surface, and here also a vertical surface. So these two components will cancel out. This is why we can say that this component will cancel out this one. So we don't, when we do the summation, these two will cancel out each other. Okay. So we still have the force applied F horizontal, we'll call it, if you want, F horizontal on AC. And we will see together when we apply equilibrium that the force, the horizontal force on AC should be in equilibrium with the horizontal component of the force of the curved surface on the fluid, because these two will cancel out. So we don't have in the horizontal direction, the only remaining forces will be what? If I write sum of forces along horizontal direction equals to 0. You have here, they called it F, if you want, we will call them FCD and FBE. So we said that FCD and F on BE will cancel out. Okay, so when I sum them, I will have the following. I will have plus, if I consider this is my positive direction, I will have plus FCD minus FBE, and these two, I can cancel them now, plus the horizontal force on AC, FH on AC, minus FH, and this is which component? This is of the curve, component of the curved surface, the horizontal component of the force of the curved surface on the fluid, equals to 0. So what can I deduce? So I can deduce that the horizontal force FH of the curved surface on water is equal to FH on AC. So what can I say now? I can say that the force of the curved surface in the horizontal direction, okay, is equivalent to the horizontal force on area AC. So area AC will be determined by this length and by the depth. So you have a certain depth, okay? So consider you have a constant depth here. Then what will happen? The force exerted on the curved area, okay? So here you have a curved area, okay? Let us plot it like this. So let's say you have this, okay? You have here a curved area. This curved area, if you project it on the vertical plane, it will give you what? Okay, imagine this. I will try to draw it in a good way so you can see it clearly. Okay, here you have a curved surface. Okay, this is your curved surface. Okay, imagine that you project your curved surface on the vertical plane. What you will obtain? You can try to project point by point. The projection of B will give you point C. Let's say if I take a point in between, the projection of this point will give you this one, and etc. So you can deduce that the projection of the curved part BA on the vertical plane is CA. And if you do this for all points of your curved surface, then you will obtain, since you have constant depth, let's say, so if you project all depth points, you will end up with this. Okay, so now I will draw for you the projected surface. The projected surface has a height of CA and has a depth D equal to the depth of my surface. So if you have a depth of your surface D, when you project on the vertical plane, then you will end up with a rectangular area. And we demonstrated together that the horizontal component of the force exerted by the curved surface on water is equal to the horizontal force acting on the projected area. And we have developed together how to find the force acting on a flat surface. Okay, so the advantage here is now that you can use all formulas developed before to get FH, because all you have to do is to find what is the action of water on this vertical rectangular surface, and say then that this will be equivalent to the force acting, the horizontal component of the force acting on the acting on the fluid from the curved form. Okay. Any question on how we determined F horizontal? Okay. Now we will move to how to find the vertical component of the force of the curved surface on the fluid. So now to get F vertical, now we will do the balance along what? We will do the balance along a y direction. So if I consider this is y, or we can call it sum of forces along vertical direction equals to 0. So as you can see, you have plus F vertical minus W1 minus W2 minus, if you have, let's say here air, or you can say it's minus W air, or you can just replace it by, this is equivalent to P atmospherical or P at dE, the pressure exerted on dE, times the area, this area here. So area is dE times the depth. So if I have a certain depth here, we should multiply the pressure acting on dE by the area, which is dE times the depth. Okay. Now, in general, as I told you, in the majority of cases, we neglect the air effect compared to the fluid. Okay. But in case we impose another pressure, instead of P atmospheric, we impose a very high pressure, let's say, it cannot be neglected. All you have to do then is to consider P times A, of course, if it's a uniform pressure. If it's not a uniform pressure, we will do integration. Okay. So now to summarize again, in the following slides, we'll summarize our findings. So first, for the horizontal component, it's defined as the force on vertical projection of the surface, and we can use all previous developed formulas. So if you remember, we have proved that F horizontal is P0, and in the majority of case, P0 is the atmospheric pressure, but to be general, you can just say it's P0 plus rho G times H of the centroid, okay, times the area. Now concerning YCP, which is the location of the force, okay, here this formula is just given with respect to another frame, and at the end you will get the same result. So if you remember, we talked about the possibility of providing variable frame to find the position of center of pressure. So to remind you of this, in general, let's say you have this vertical surface. If you consider the origin of Y from the free surface, then YCP, we developed together that YCP is Y of C plus a certain length, which is the one we developed in the formula. Also, you have another method that considers just the distance between the centroid of the area and the center of pressure. So in case you want to determine directly the distance between the centroid, this means that you take Y axis on the centroid. So if you take it upward, if you take Y axis origin on the centroid and you take it upward, then since YCP is, since the center of pressure is always below the centroid of the area, you will get that this YCP is just minus, because it's below it and you have Y positive upward, it's minus this term. So if you compare, it's exactly the same result we obtained using the previous formula. I'm just providing you with different formulas because you have problems. We are doing problems from different books, and each book uses a different notation. So it's just for you to understand that both formulas will give you always the same result. So just I changed origin, okay? Instead of referring to the position of center of pressure from here, now I am referring from the centroid of the area, and instead of taking Y downward, I'm taking it upward. This is why you have here minus times this distance. And this distance is exactly the one we obtained in the previous demonstration. So YCP can be calculated from the centroid of area as rho G sine theta times Ix over F. So this is the result we proved last time, okay? And now, since we are considering vertical projection, so what is theta then? Theta is 90, okay? Because here this demonstration was for any flat surface with any orientation theta. Now, since we are projecting the curved surface on the vertical plane, so the theta here will always be for our projection, theta will be 90. So you have to replace theta by 90 degrees. And all of these properties, depth of center of centroid and the area and I-x-axis, okay, will depend on the projected area. In general, the projected area is a rectangle if we have constant depth. So we'll deal then with a rectangular area, okay? Now, if it's any other area, if the area is not rectangular, they should give us what is the projected area. So for example, here, let's say, they can provide you with the following figure. This is our projected area, and we will proceed. So as I told you, in general, we give you common surfaces, rectangular projection, triangular projection. So any shape that will be easy to work with, okay? Because if not, we should perform integration to be able to calculate the area of this projected surface and to calculate I, okay? This is why in general we deal with common shapes, because for these common shapes we know automatically what are formulas of area, what are formulas of I, and we'll see together that in case we have a general area, we can go over integral procedure, okay? Any question on this? No. So here to summarize, yes,
بس
yes,
بهذا الكورس احنا عندنا common shapes بيكون مش هيك؟
مظبوط. اوكي، لانه
دكتور
نحن
بهذا
ما
الكورس
رح
بيكون عندنا
نفوتكم
common shapes
بقصص
مش مظبوط.
integration. هلا sometimes الانتجريشن مضطرين نعوزها بالكيرف سيرفيس بس مش بالبروجكتد اريا. عاده البروجكتد اريا بنعطيكم اياها كومن سيرفيس فما تضطروا تجيبوا انتم الاي اكس اكس والاي اكس واي باي انتجريشن. اوكي،
اوكي دكتور، عرفت شيء باللاندد او
sorry can you repeat؟
عرفت شيء بخصوص next month اذا رح يكون بالجامعه او اونلاين؟
بعد ما عرفنا شيء. اوكي، so I will tell you when I know. Okay, when it's when they tell me, I will directly provide you with the information. So now, concerning the horizontal component of the force on a curved surface, okay, it is equal to the force on the plane area formed by the projection of the curved surface onto a vertical plane normal to the component. And for the vertical component of pressure force on the curved surface, it will be equal in magnitude and direction to the weight of the entire column of fluid, both liquid and atmosphere, above the curved surface. Okay, I know that it's hard as material, but now when we do problems, it will be clearer for you. Okay, now this figure, this slide illustrates for you how we can divide the two components. So we will work with two components when we deal with the curved surface. We'll deal with a horizontal and vertical component. Now concerning the horizontal component, as we said, we do the projection of the curved surface on a vertical plane, okay? And then we determine from analysis of flat surfaces what is the component of the horizontal force and what is its point of application. And for the vertical component, we say that it is equivalent to the weight of liquid above the surface, okay? And of course, if we have atmospherical pressure, we can neglect the atmospherical pressure effect compared to the weight of the fluid, especially لما يكون عندنا water and fluids with high gamma. Now, in case we impose any high pressure here and we want to take it into account because it's not negligible, then we should find the total force acting on this part. Okay. Now, here, they are telling us how to find the points of application. So for the horizontal force, how to get the point of application? So as we said, we use the developed formula for flat surfaces, that y is equal to yc plus ix over a times yc. Now, what is challenging a little bit is